So, uh, in the process of trying to figure out the best way to get the TV into AV mode from the outset. So yeah, wouldn't have to do any delays at that point. Just basically stick it into AV mode and switch it into RGB, and we're golden. The other benefit of that as well is that we could do this, as the TV is being put into service mode. So yeah, looks like I might be onto something. So first of all, let me explain what I've been up to, how I've gone about it. Is essentially I've taken a dump of the bus. So I've put the bus pirate into sniffer mode. One of the things I found with this particular mode is that there is a bit of garbage going on, and there's some corruption. You can see, there's sort of beginnings and endings of messages, but then sometimes there'd be just throughout, there'd be like these kinds of responses. Now these might actually be responses from these requests. Maybe that's what that is, but we don't see them. We don't see them sitting inside a start and an end message. So this is the start of an i2c message, and this is the end. And the other thing that you'll see is that there's these pluses and minuses around the place as well. So plus is an ACK, minus is an ACK. And so when I sort of take all this stuff up and start to break it down into kind of logical groupings, I guess, and then start to align that with the documentation for the VDP, I can see that there is, there's obviously messages that are going. I've then used the documentation from the data sheet to then look up what each of the locations are. Location of the registries. The registers within the actual VDP. This particular VDP has kind of like two ways of addressing it. So it's a little bit more complicated than what I had to do for the RGB hack. For the actual RGB side of things, it was just talking to the straight registers within the VDP, but the video display processor has, like I said, two different types of addresses, and it's got this called FP subaddress, and that FP subaddress is to do with the what they call the onboard fast processor within the VDP. So you can see control registers of the fast processor, and to speak to these, you've got to craft a special kind of set of messages, i2c messages, that talk to the registers of the normal registers. So you sort of speak to these special registers via the normal registers, and that's handled by this FPSTA and FPWR, and also this one here, which is this message here is a FPDAT. So FPSTA is fast processor status, FPWR is FP write, and FPDAT is FPA data. I'm not quite sure how the reading works, like how the status kind of checks work and things like that. But at any rate, the ones you can see, like here, it's doing a read. What I did read, obviously, when I've gone through the VDP documentation, I'm looking for something that would help me to figure out the selection, the input selection. So the AV selection. One particular register that I was interested in was this 21. Looking at the schematics for the television, you can see that basically this is the VDP. There is a AV1 in signal, and that goes into pin 4 of the VDP. So it became obvious that perhaps the VDP actually does the channel selection as well. So it has a series of signals coming into it, and you can tell it which one to use. Much like how the RGB hack works. So the RGB hack kind of does the same thing. There's several inputs for RGB going in, some fast blanking pins and that kind of thing. And essentially what I'm doing is forcing the VDP to use those signals for output via its RGB out, which is there. So anyway, back to sniffing around in the output. I just then sort of started to look at what was going on. I think that it could be a combination of signals to get things to, combination of messages to get things to happen. So at this point in time, what I've done is I've combined these two. Which ones was it? It was one of these ones I've combined together and just turned into a normal message. This one here. So this one in particular, this looks very, very good because it's got this O3, and when I look at the documentation for the O3, what that byte would be, that is actually dealing with the input selection for VN4. So if I just find 21, so the first couple of bits, and you can see that if you put a 3 in, that would be VM4. So it definitely looks like it's trying to select VM4. And yeah, so sure enough, let's try issuing that command. So just got Putty obviously hooked up to the bus pirate, and I'm just sending through the signal now. So you'll see, get some sort of funny black lines down the bottom. There you go. Poof. So it actually jumped to AV. I think I might have issued too many commands. Unfortunately, it's just a matter of sometimes not getting all of the ACKs. You can see like where it's responding with NACs. I think when I get all of the ACKs, when I get all ACKs from all of the oh, let's really squash that picture. No. Yeah, you can see it's very unreliable. And this is, oh, there we go. And it jumped in and it jumped back out again. You can see that it kind of almost did everything. It's like, it's got all the ACKs except for the bottom one, which has come back as a NAC. But it did jump in there. I just can't get it to stay there. So, oh, there again, it did it again. So, it's definitely looking like it's possible to get it to go into AV mode. So yeah, I guess the next step is just to try and refine it, find out the exact sort of message that I need to send. Maybe I don't need to send those two messages in combination. I don't know. And yeah, and then hopefully then I'll start to put that into the program that I stick on the Arduino. And then yeah, I will give you guys another update when I'm done. All right, cheers.